This is an experiment for amplidyne. Amplidyne is a high gain amplifier, and the circuit diagram is to be connection diagram should be connected as per the circuit diagram given in the manual. It is like a DC generator, two-stage DC generator. So the small input is provided from UPS, from RPS, and we use the auto transformer to run the prime mover, that is the three-phase induction motor, to run the DC generator, the amplidyne, to give mechanical power. And we do the load characteristics and open circuit characteristics under various compensation: overcompensation, undercompensation, and level compensation. Overcompensation means more current flows through the compensator winding. That is by making the resistance maximum. If you make the resistance maximum, since resistors and the compensator windings are parallel, if the resistance is maximum, more current will flow through the compensator winding. If resistance is minimum, more current will flow through the resistor, so less current will flow through the compensator winding. So under compensation. Level compensation means we will find some between middle sweet spot such that a correct amount of current flows through the compensator winding. And metadyne means when there is no compensation, we will short this rheostat such that all current flows through this by this short circuit. That is metadyne. We are doing this compensation because armature reaction should be overcome because of this compensation. If we don't add compensation due to armature reaction, the output voltage of the generator will be reduced. To compensate the armature reaction only, we are adding a compensator winding. So we will start with this. First, to open circuit, for that we will switch on this. Now we need to run the motor. We give around 65% tapping is fine. Now we started this. Now we will give a input milliamps of 5, 10, 15 milliamps, 20 milliamps till 30 milliamps and take the open circuit voltage. Now for 5 milliamps, we see the open circuit voltage. For 10, open circuit voltage. Similarly, we will be doing for 5, 10, 15, 20, 25, 30. Till 30 we will do. So after 30, we will get the open circuit values of the IF. That is the field current, that is the in milliamps versus the output voltage. This is the open circuit characteristics. Now we will go for load characteristics. Initially we are at overcompensation. We will connect the DPS switch. Switch on the load. First we will put on load. We can see the increase in the current. Because of overcompensation, the output voltage increases. Second load, again we can see. Third load, 3 loads we introduced. Now we will do for undercompensation. So some minimum value we kept. Now again we are loading the motor. As a reduction in the voltage slightly, and a good amount of reduction we are seeing. Now a level compensation. We are going to find the seats middle part where the output voltage of the motor should not vary much for full load. A slight variation is there initially, but when we load, there is no much change with the consecutive loads. So from this we can see this is a approximate level compensation. Now we go for metadyne, that is completely short circuiting it. So complete short circuit. Rheostat means full current flows through the rheostat. No current flow, very minimum current or theoretically no current flows through the compensation winding of the amplidyne. So from this we can see when we load, the voltage is dropping very low. So this is the meta-dyno. This is the overall experiment of taking the open circuit characteristics and load characteristics of a amplidyne and a meta-dyne. And we can reduce the motor, switch off the motor, reduce the voltage, input voltage, and switch off.